session is particularly about integrating Actor Framework with gRPC. Again, just a quick question. How many of you have heard of gRPC or used it? Okay, good. So you know the session you're getting into. Okay, so then here we are. We have one of the biggest program developments using Actor Framework, and we have a sizable big team, and we have pretty big repository with tens of thousands of VIs. Everything is going well. We are in our own bubble, so to speak. Everything is fine, but at the same time, we are wondering, with increasing complexity, our programs are getting more and more complex. At the same time, we are seeing other programming languages, especially the text-based programming languages, are rapidly evolving in terms of their capability to support with open source libraries or whatnot. And what we are also realizing is there are many custom specific solutions that we develop for the complex problems that we go after. And these, as much fascinating as they are, induce pain over long term. The programs that we develop literally must stand the test of time. They are maintained for 10, 20, 30 years. To give you a scale of the problem, we still to date deploy and support the LabVIEW code that was released in 6.1 more than 20 years ago. So needless to say, longevity matters. Anything that we introduce that's very specific, fascinating, we have to see through the longevity lens. And the other piece is we are a very multidisciplinary team at KLA. Software is a piece of the puzzle, but it's not the whole puzzle itself. So we often get requests from our systems engineers, especially saying, you have this cool infrastructure, software infrastructure that's very complex. It does very incredible things, but can we control, do our own thing with your massive infrastructure? And often it's not a simple, seamless ability for us to enable. And the last thing is, of course, as with everything, we want to keep the solid design principles in mind, such as single responsibility, dependency inversion, and open closed principles. While keeping all of these, how do we make sure we keep ourselves relevant in this rapidly evolving software world? And now, when we are in the Bay Area, of course, we have peers we talk to that don't use LabVIEW necessarily. And what we've been learning is there are microservices and other fascinating protocols that evolve that are language agnostic. Some of them, the one that we're going to particularly talk about. And we constantly ask ourselves, how do we leverage what's out there to basically harness the power of what's evolving without significantly tweaking what we already have? And seamlessly, we have, again, the piece of the software that we use LabVIEW to develop software for is, again, one small piece of the big puzzle that has multiple facets to software development. And how does such interface hypothetically enable seamless integration with other software subsystems? And how do we expose the APIs, again, for external users who don't necessarily have expertise with LabVIEW to seamlessly accomplish what they want to accomplish? And then there is the answer, gRPC. And now we'll briefly introduce what gRPC is, and then more importantly, talk about how we integrated gRPC with Actor Framework. With that, I'll hand over to my colleague, Ian.
Thank you. So here we go. Getting back into what is gRPC. It sounds like a lot of you in the audience, and possibly online if you found this video, are somewhat familiar with it or are already using it, which is awesome. For those that are a little bit less familiar, we are going to go through what is it, and then get into a brief fun slide about what is Actor Framework, and then into the really interesting stuff. So what is gRPC? It stands for Remote Procedure Calls. I know someone out there is going to be like, well, G actually changes every single time they release it. It's one year it's this one. We know it's Google. You're Google. You wrote it. You know you named it after yourself. It's cute, but we know it's okay. It's a communication protocol. It's to talk between systems, and that's all very vague and good. The communication's hard. If I should try to describe something, it's tricky. If I were to hold this up and say, Sasmarth, it's hard to know what I said unless you know what's important to me. If I try to tell you what is gRPC, I would be telling you what's important to me about gRPC. So I'm going to start with what was important to Google when they were writing gRPC, at least as far as we can tell, and then into the other things that gRPC has, the other kinds of functions and functionalities. So I might have said cup, I might have said glass. Google, if you had asked them in 2016, they probably would have said something like this. They probably would have said, we need to be something that's high performance, that's very performant. So we know we're going to need to send binary information rather than strings. Just sending JSON isn't going to be good enough. We need to be self-writing. We need to be able to generate code automatically because our engineers have other things to do. And we need advanced streaming, and we need it to be cross-platform. We need to move away from things that are very tightly coupled to this particular use case. And there are some things that do something similar, but this is what they, as far as we can tell, we're aiming for. But that might not be what's important to you. If you were trying to pick our gRPC, when we were trying to pick our gRPC, some of this applies, but not all of it. There's a lot more to gRPC. The things that matter most to us at KLA is that it is language neutral, that it has cross-language support, and critical for us is that it's already widespread. It already has been adopted by many other industries, which was definitely not true in 2016 when they wrote it, because it was brand new. I mean, RPC had already existed, but gRPC was new. But even if those two things or the previous list from Google isn't important to you, maybe the other things about it are important to you. It being accessible, so it has very strongly typed contracts, which makes it a little bit easier to onboard new engineers. They don't need to understand the whole system. Just get this contract proper and ever right. And that has clear documentation so they can do it safely. It's secure. It's using good security. And it's mature. It has good support in active community and I'm blanking on open source. It's open source, which is wonderful. So that's an attempt at what is gRPC. So how does it work? So basic diagram, you have a very clearly defined API contract, which is called the protobuf. It goes into a protobuf compiler called the protoc. And for each language, you have a protoc for that language, and then it generates code for that language. And that runs, and then you have code that you can then use. And you don't need to write all that code for every time it changes. That's lovely. Hooray for open source. Thank you, NI. Thank you for all the Git repos about gRPC. Thank you for the Git repos for Actor Framework. That's been awesome. And this is also on VIPM. So thank you for JKI for putting together VIPM all those years ago. And yeah, this is really great. This is all, as far as we can, when I last looked, it was all MIT license. So that should be accessible for everybody. I'm going to do one slide on Actor Framework. And then we're going to get into how we merge the two things. So for those that aren't familiar with Actor Framework, it is object-oriented. We're using classes. It's effectively a queued message handler. It's mature, it's well supported. There's the GitHub again. You have an actor that is a class, and it runs as a class. It runs, it has a process. Inside you have APIs that you define, very nice. You have messages for each API. These are also classes. You have a message class. I'm going to be using this language medium of a little envelope to indicate message classes. Inside you have private data and a message queue. Well, technically a reference to a message queue, but whatever. And you then launch them in a tree formation with a root actor, a caller actor, and other actors can call other actors if they are both themselves or their caller or their children. So you can communicate with ones that are adjacent in this tree formation. And that's it for Actor Framework. There are other very easy talks this week about Actor Framework. So now we're getting into, okay, so how do we use Actor Framework with LabVIEW, with gRPC, and how do we build with gRPC using this pattern to get access to these other languages? We're going to focus on Python, but really this is language agnostic, which is the whole point. So we're just picking one out of a hat. We're going to build this diagram over the next 7 slides. So please don't try to understand this whole diagram right now. If you are, I'm sorry I put this up there. But the point of this slide is to say we're going to have LabVIEW over here on the left, We're going to have Python over here on the right. And the majority of these things are actors. There are a stack of classes, of LabVIEW actors and LabVIEW classes, but that's generally going to be the flow. We're going to be building this up as we go along. So here's the first step. Here's our normal architecture that we're already using that our developers or LabVIEW developers are already used to. They have their hardware actors that talk to hardware, do hardware things. We have GUI actors where the user actually clicks and does things. And we have the launcher actor that does some coordination. And that is fine. Our developers develop their APIs and do everything as normal. They don't need to know a whole lot about what we're about to go over. We generate the protobuf files by parsing the NI actor messages with scripting and other kinds of fun stuff. This is automatable, which is really, really, really lovely. We take these protobuf files that are generated, the strongly typed protobuf files that define those APIs. We send it through the protalk, language-specific protalk. So first we're going to go down the LabVIEW cycle to generate the gRPC server class. And this is using the protalk developed, released by NI. This is out of the open source GitHub. So the gRPC class that's being produced here is being produced by that normal pathway. You can then do a little bit of magic, a little bit of dancing, and get this to incorporate nicely into a gRPC server actor. And then from this server actor, it's able to call the messages that were used to generate the protobuf to go through the protalk to generate the gRPC server classes. And this ends up being our connection between our traditional actor framework that our developers are using to the outside world. And where is that outside world? That outside world has been produced by going through the Python protalk to create a client stub or collection of client stubs, which is then callable by the external Python scripts. The nice thing is that this cycle is not part of the normal developer experience. The normal developer experience, they're working over there on their GUI actors, on their hardware actors, and this sequence can be run more or less automatically. This can be automated. This can be done procedurally, which is really, really fun. Here is kind of a simplified version of what those different steps are, where yellow are the parts that we've automated with things from KLA and our partner Soliton. Thank you, Soliton. There's another byline for them later on as well. But yeah, the key magic parts are generating the protobuf file from the NI actor messages and this gRPC server actor and getting it to connect nicely, I would say seamlessly, because it's a fun word, with the generated server classes that come out of the protalk. This is a good place to pause for questions, because that was a lot of slides and a lot of arrows. We all love wire diagrams, but it seems like a good place to pause.
Yes. Do we have a mic or?
If you don't have a mic, I'll try to repeat your question as best I can.
And you might answer this later, but it looked like for all the actor messages between all the different actors all the way down the tree, you're creating a protobuf message for each one of those.
For the ones that matter at the top, like this is simplified. I'm not going to say this isn't simplified. There are potentially many things under the iceberg, many other actors under the GUI actors, many actors under the hardware actors. We're not exposing all of those messages. We're exposing the messages that we want to be accessible.
Only selective subset of the messages that are relevant for our stakeholders.
Are they at all levels of the tree? I mean, anybody can talk to any actor in the tree there, or you have to have going through.
There is no limitation on which level should they belong to. You're right, but the limitation primarily comes from which APIs do we choose to expose as a part of the interface.
So to repeat the question was largely, are they messages that we're exposing to everybody? Is it the ones at the top? Is it the ones at the top and the middle and the bottom and all the way down? Because that can be a lot of actors that can a lot of messages that can potentially expose things that you don't want to expose to make it safe. And that's, I don't know how we programmatically prevent us from doing other actors. I guess we can.
Yeah, if there is any concerns that intelligence can be baked into the gRPC server actor to filter any messages that are not relevant to be let through.
There are ways. Francois?
Yes. So how do you know when you're a Python client, which, let's say you have 3 power supplies, you want to control one, how do you know which one you talk to? Is there some addressing, some routing, some?
So sadly, editing the Python scripts is always going to be manual. There's some amount of, oh, sorry, I was supposed to repeat the question.
Part of the protobuf, right? Protobuf is about the type.
Yeah.
List of APIs available, yes.
So here's an example. So the question is about the protobuf, how we get this plugged in. At least this is going to be part of the answer to your question. So here's an example of a protobuf. It defines the input cluster, or the collection of data that's going to be going in. But this is going to be from the actor message. So the API for Python, or the script in Python, doesn't necessarily know this until, I guess you feed it in from the protalk. But does this help ground
If there are multiple power supplies, each would have their unique references. That would be part of API input.
Well, let's say they have all set voltage. They all have the same protobuf, exactly the same API. How do you know from the outside? How do you discover where to send that message to talk to the right component?
Yeah, the ID.
So in that case, when exposing the API, we would abstract, maybe give some alias names and make that as a part of the input. Okay, set voltage, the first input is power supply identity, ID, right? So when the Python API sends a message, it needs to explicitly specify, in the event there are multiple supplies, what's the reference?
Which you probably would have had to do from a GUI actor as well. If your GUI actor needed to talk to some hardware and get the correct hardware, the GUI actor probably also had to have some kind of alias or index to do that.
I have a question.
What if there are 2 benches that we want to talk to from one remote computer? How do we need to send, where do we set the endpoint?
Where we set the endpoint, if we have more than one bench that's the same, but you want to access them from the same remote computer.
There is no limitation. The server can connect to multiple clients, but I'm sorry, I didn't quite.
Now I want to specifically connect to client 1. They have the same gRPC messages, exactly identical. But I want to connect only to a client 1. Next time I want to connect to client 2, 3, 4, but they all are sharing the same protocol.
You want to restrict to one at a time?
Yes.
We haven't had that use case, but I can totally see how we can restrict that in the server class.
Because one reason to use gRPC is to access multiple benches remotely, like a dashboard. You have a dashboard. You would be able to talk to different benches. How would you distinguish between different benches?
Each client will have its own client ID as well. Yes, and the server, at the time it receives a message, it can clearly distinguish what's the client which.
But what's the server here?
So the server is LabVIEW in this case.
But in that case, we will have 8 servers, right?
One server per bench.
Yes.
One server per bench. It depends on what is your server doing.
So all the servers will receive the same message. They look at the ID. If it's for them, they will accept it. If it's not them, they will discard it, basically what you're saying.
That's the point, isn't it? Client to server.
It's not necessarily point to point. The server can connect to multiple clients, running in multiple languages. But if your hardware setup is so specific for bench to bench, you could choose to have a server instance and the client instance per bench. Or I thought you were mentioning earlier where you have a centralized infrastructure that you want to tap into from different benches. That would be a centralized server and multiple clients tapping into the server. Either way is possible depending on what you're trying to accomplish. In our case, it's a single server running on LabVIEW side because that's where our massive infrastructure is, running complex machine control. And the clients are basically our systems engineers running their scripts.
It almost sounds like you're describing this diagram kind of flipped, where your server is exterior to this system, and then this would be the client side. But in our system, it's or put our server over there, which is, both are valid, both are very doable.
Possible,
It's just
yeah.
a different perspective and flip.
Is there a way that you can know where the message is coming from, like IP address or something like that, embedded on the gRPC?
The question was, how do you know where the message is coming from? Like, is there a source IP address or something like that? Yeah, my understanding keeps, I'm sorry, like a broken record. I keep thinking of it just like, there's just a bunch of tags. There's just a bunch of IDs on, this is the client ID, this is the server ID. Is that?
But I bet there is a way to configure this client IDs associated with this IP address. Yes.
So here's an example of a protobuf file.
This is the
text.
live demo we'll be seeing in a minute. The protobuf corresponding to the live demo we're about to show.
Yep. You're going to see this OCR request, OCR response, or process OCR request, process OCR response with the inputs and the outputs that are going to be expected. This is what the LabVIEW Protalk produces. It produces this client, and you can see AI automation client. You can see the AI underscore automation, and then AI underscore automation over and over again in what's generated by the Protalk. And again, those repeated phrases. This is generated nicely by the Protalk. And this is what we end up generating and working with from there. The messages.
Yes. In this particular,
Yeah, it's a bit fuzzy.
In this particular example, though, the server is on the Python side. LabVIEW is running a client. Okay, we're ready to show the demo?
Yeah.
Okay. Maybe it also helps to show this diagram briefly and this one. Yes. You want to talk to this a little bit?
So I'm going to fly through this so we can get to the demo. But the gist of it is what we're trying to simulate, what we're trying to demonstrate is part of what the sequence would be. On a normal sequence, a request comes from a GUI to send a message up to the launcher, down to the hardware actor to say, do a thing. Image goes from there up over and then down to the GUI actor. It then goes up to the launcher actor, down to gRPC server actor to say, I need you to go process this. It goes through this sequence over to Python. Python does some magic. Data comes back to the gRPC server, and that response gets bounced up and then back down to the GUI actors. The site is a lot to read. We're not going to read this right now, but it is going to be available in the presentation, in the recording. And basically it just goes through all that with proper terms and everything. So the part we're going to be focusing on for the demo, to keep it small, succinct, and easy to work with, is mostly just the gRPC side. We're not running a whole camera right now, but that's okay. Moving on to gray slide demo. Run it now.
Yes.
I'm going to move to that side of you.
Yes. Okay. So this is the LabVIEW Actor, and this is the Python server that's already instantiated and running, waiting to receive API calls from the LabVIEW client. And this demo basically has a collection of all the handwritten characters put in a folder, and this utility randomly picks and cycles through them, running those images through the Python side that runs character recognition algorithm that's running in Python. And you can see the response that's coming back. This is an off-the-shelf API library that we're using from Python, and it's not accurate. And as you can see, more often than not, it's not correct. But the point here was to show that we were able to integrate the actor framework with off-the-shelf libraries that are available in Python. This is one example. And the other example is one of our developers was so passionate about this demo that he went as far as running a local LLM on this laptop and just run a question here. And then this question makes its way to the Python side, and then the response is received in a streaming fashion. Tell me one more question, Ian.
Do you like LabVIEW?
Do you know what is LabVIEW?
Let's see.
Okay. Let's see what it says. Well, needless to say, this is a very...
If it were running in LabVIEW, it would know what LabVIEW is. So you can tell it's running in Python. Python doesn't know what LabVIEW is. So if anything, this is just further proof that we really are communicating out of LabVIEW into Python, and then Python responding back.
And
which
also,
is really the point.
You correctly, so yeah.
So this is also a very low-end LLM. Do you know which LLM it was?
It's really tiny.
It's running locally,
It's running on the laptop.
Locally on this laptop, really to show the power of what we can harness here. But any questions on the demo?
So in this example, you're kind of kicking off the communication from the LabVIEW side, and you're messaging out to some Python, Python code that's already running, and then it's sending an actor message back into the LabVIEW application, basically.
Correct.
Right. So the formatting of the outgoing message, you just have to kind of like manually code up somehow, or because you're auto-generating kind of the incoming messages to the LabVIEW app.
So it all goes by the protobuf definition, right? So the API call that goes from LabVIEW to Python, there is a protobuf, which is language neutral definition of what the API inputs are.
Yep.
We have automated that, as well as Ian said, the entire flow is automated, and so is the response coming back.
Okay.
Two questions. Is there a limit on the payload size? Can you stream large images very quickly?
In fact, gRPC, one of its strengths is really streaming large volumes of data. In fact, yes, NI, as a matter of fact, NI, as for all its instrumentation drivers, as we recently understand, they all use gRPC under the hood.
Okay. The second, is there any, so this is a one-to-one example. Is there any like end-to-one or publish subscribe, discovery of services, that sort of thing built into gRPC?
Yes, so most of that functionality, especially when it comes to client and server connection, registration, and health check, is all out of gRPC native library that comes with it, right? So we use the API communications on the top, and all the encryption and all the underlying layers come with gRPC.
But could you publish, could you stream from one device to many subscribers, or vice versa, could many different things push data to one sync?
Yes, as far as I can tell, there can be many clients, multiple clients that can connect to a single server. And that, how do you configure, however you configure client and server infrastructure?
Do you have to manage the connection manually? I see your disconnect and connect buttons up there.
No, we don't. Just whenever the client side starts, the server recognizes a new client has connected, and whenever the client stops, the server just acknowledges the disconnection. And because gRPC, for what we are doing, is just interface with the rest of the world, right? So we already have a lot of software activities, calibration activities going on within LabVIEW itself. In other words, we are not a slave to a connection request that's coming from the outside.
Actually, an extension to that question is it guaranteed that the messages will arrive on time and in order? Does that make sense? Is it guaranteed that messages will arrive to the destination?
That's a good question.
If you unplug it, it probably won't, but.
Yes. I don't know if there is, but gRPC is pretty low latency. The fact that it's used for image streaming and high throughput streaming is the fact that it's pretty lightweight. It's encrypted, it's low latency, but in terms of, if your question is, do you guarantee the receipt of the message? Is that?
I think if it's over TCP, it would be guaranteed to arrive or to know that it's not arrived, and it would arrive in the order that the packets were sent.
So we do have control if it is TCP or UDP?
Yeah. Yeah, if it's UDP, you're not sure.
Yeah,
But
exactly.
if it's TCP.
This is TCP, yes.
Okay. And is the connection like when you said that it knows that it's online, but if it goes offline and comes back online, does it reconnect automatically, or we need to check that if it is connected all the time?
That
I
particular
haven't had
piece,
problems with it, but
that particular piece, I'm not sure if there's a constant loop that checks the connection and reactivates if the connection is broken. I'm not sure. Maybe Casey, do you know? Probably not. Yeah. But given how universally used it is in microservices in the software industry, I would think it's part of the infrastructure that comes with gRPC. Or at least it makes it seamless to do that. Yes.
So I think the protoc will generate a cluster, right, of data structure, and is that includes the message payload, I guess, and it has a message queue in it as well?
no.
Or a queuer, I guess, or?
No, so the output of protoc is fully independent of rest of context. It only splits out LabVIEW code and the corresponding Python side code in the context of just gRPC transaction.
Right, but it has the payload of your message, right? Or
It's the serializer and deserializer. Is the
Yes, it's included.
Yeah.
There's no engine. You need to do it. That's why the server, the actor server is there to provide the engine.
Yeah, the enqueuer is in the gRPC server actor. It doesn't exist in the gRPC server class. The gRPC server class provides the APIs for the request response to APIs that it's going to be using.
Well, okay, yeah. Well, I guess my question is that, if you're sending a message across, you're sending it the contents of the message,
Yeah,
right? Which is a cluster of values.
of data, yeah.
Does that cluster include the messaging queue?
It does not include the messaging queuer.
Okay, so from Python, how do you know where it goes? Or how do you?
Because both Python and LabVIEW, they both register by the contract, which is the protobuf file. So the protobuf file has the definition of the function itself, as well as you can define data types, which can be nested cluster.
Well, how do you know where to send your response back to? Is that really what you're saying?
Yeah.
So your question is what response to expect for a given API? How is
Well,
that?
if the request comes in, how do you know who requested it and where to send it back to? I assume that's obvious from the API. But
Well, when the request comes in, it has the client ID, right? So the response will be sent back to the same ID.
so it's outside the protobuf.
Yes.
I think you're kind of asking about routing within the Actor Framework application, kind of.
Yeah.
Like, how does it know what the right destination is once
Right.
it receives a message from?
Within the Actor Framework.
What's that?
Yeah.
Yeah. So I think you guys have developed stuff under the covers in like your gRPC server.
This part works.
Okay. We're served a message that's
Yeah.
read voltage for this type of actor or this specific running actor. Then internally your code routes that through your actors to the right thing and does the thing.
Yes.
So you're saying the queuer doesn't go as part of the message coming over from the Python side. The LabVIEW code that's running in the gRPC server figures out how to do the routing and which actor they're actually trying to talk to.
So there's
also
some
the response
custom code.
that needs to go back.
My apologies. Yes. If your question was in context within Actor Framework, yes. The gRPC server actor knows the associations. When an API comes in, it knows the association, which actor does the API belong to, and it does the routing.
Somewhat similarly, if you kind of kick off something from the Python side, right, where you're like, hey, read this voltage, say, and you send that message across to the Actor Framework side, and it does the voltage, can you make the call on the Python side like a blocking call where it messages into the Actor Framework application, requests a voltage read, and then doesn't finish the call until the voltage actually gets sent back to it?
As we have things written down, it is a blocking call.
It is a blocking call
It
on
is
the
a
Python
blocking
side.
call. Yes.
Okay.
Yes.
Instead of using something like Python, do you have any experience using this, LabVIEW to LabVIEW on a remote computer, or would you consider a different method for that?
LabVIEW to LabVIEW, we didn't, although it's in theory possible. That's the power of language neutralness of gRPC. But the whole reason why we explored this path is to enable channel into LabVIEW from other languages. We are doing prototypes with Python, although we have other stakeholders that are interested in writing .NET scripts. That's good news because this is language agnostics. You just need to get Protalk for .NET and generate protobufs and create scripts in .NET.
Okay, so you don't see it an issue there to have like an active server on one computer, active server on another computer with gRPC in between?
Totally language neutral. Both ends can be same, different. You can mix and match.
Regarding that,
I was gonna say, if you're trying to go actor to actor on two different applications across the network, there's probably way easier ways to do it.
Okay, that kind of was.
Oh, actor to actor, yes.
Yes. There definitely are.
Okay.
Unless there was like a driving desire, or you wanted to make sure that you wanted to swap from LabVIEW to Python in your other environment. You're just like, oh, I have Python here. I actually want to scrap all the Python, do this LabVIEW version, leave LabVIEW on your hardware side here. I guess you could. Like sometimes you're talking to the Python version, sometimes you're talking to the LabVIEW version. That sounds, I'm going to call it exciting.
Thank you.
Any other questions? We have time.
Yeah, we got another, yeah, we have plenty of time.
We have plenty of time. So now just want to share with some of the major takeaways here is the entire flow is automated, meaning we're very cognizant about our design choices from the beginning. We, of course, the beginning piece of somebody on the developer team exposing the API, it's of course very domain specific, use case specific, that is manual, that can be automated. But taking that API in LabVIEW Actor Framework and making it available on the Python side, all the links are automated. And to an extent that the underlying library, when somebody does auto finish, press on tab in Python, it will pick up the new function that's added. We have automated build process that enables that. And if somebody is really interested in some of the nuances, the Protalk for LabVIEW, because our server is on the LabVIEW side, when we use the LabVIEW NI native Protalk, it generates the LabVIEW server class itself, which as it is written by LabVIEW, some of the APIs, the API definition is hard-coded into the server class, and we wanted to decouple that dependency. That we didn't want every time a new API is added, we didn't like the dependency to go and modify our server actor, which is the core piece of the whole infrastructure that we didn't feel comfortable touching, and we wanted to keep things decoupled, and we invented a way to abstract the server actor so that any new API is essentially a plugin type addition and without touching the existing APIs and other infrastructure in place. And more importantly, this has enabled our developers to share our APIs across other software subsystems and natively have the ability to integrate with other subsystems that already use gRPC. And in our opinion, it was quick and easy. Quick is a relative term, depending on your span of lifetime of projects, but it's a one-time, good news is it's one-time effort. You don't have to do it again and again, especially if you have an automated build, it's a one-time effort and it's consistent and it's good object-oriented design that seamlessly integrated and accomplished what we wanted with our stakeholders.
Regarding the second option, the second line, could you elaborate a little on like what was the significance of Actor Framework in this data flow? Like, why was it? How is it different in DQMH or other platforms?
So, as things are right now with the LabVIEW Protalk, it would give you, if you wanted to generate an equivalent of LabVIEW server, it would have a event structure in a while loop, and there would be one single case for each API it would support. And that if you were to use a DQMH, you could seamlessly integrate that as well. But what we did was we didn't want to have the dependency to update our server class every time. So we have abstracted based on, if you're interested, we can take it offline. But it can integrate into DQMH as well. But the integration of Actor Framework is basically that piece of making the server independent of the native LabVIEW server class that's spit out by the Protalk, and the routing part. When an API comes in, figuring out which actor it needs to go to, and then getting the response back and sending back to the client.
Did you consider any other solutions, like messaging libraries, where you arrived at this? You compare and contrast, warnings, don't go this way.
Certainly, we have explored a few options. I'm trying to recollect. One of them.
You and Karthik.
What?
You and Karthik went through the
yes,
the
we
exploration
definitely
period.
went through extensive evaluation. I didn't want to give you a dumb option, which was, we obviously explored the use of DLLs as well, but that was not the only one. I'm trying to recollect others. But yes.
Zero Q, for example, it's a little more generic. It doesn't have protobuf, but
Q?
Zero Q, or like MQTT, it's these other kind of
That particular option we have not considered. Are you aware of?
It didn't appear on my list either.
Yeah, no, we were not aware of that. The main appealing thing about gRPC was its widespread adoption and stable infrastructure that was developed.
Contract, you don't have to know.
Yes. And the language neutrality. Going into this, we were very particular about not tying ourselves to any particular language, and gRPC nicely offered that feature. It already had out of the box about, at the time we had this presentation, 20 languages natively supported, which was a good indicator that it's not tied to a specific language.
Would you say that the GitHub LabVIEW gRPC implementation is mature enough at this stage? It seems like there's still a lot of issues, right? There's really weekly commits and updates and fixes and lots of bug reports. Seems very.
I've looked at the page recently. It's active, and active is good. That means it's getting engagement, it's getting fixes. But yeah, it's usable. I wouldn't say that it's not mature. I would say that it's growing to be all that it can be.
Do you think it'll be eventually pulled into LabVIEW as a core protocol?
I am not at liberty to say anything of the sort.
We hope so.
Very separate.
Yeah. Any other questions? Yes.
So, in case you're having issues with the calls or things with gRPC, which are good techniques to debug it?
In case of any issues, techniques to debug. Believe there are some native out-of-the-box tools. I'm not aware.
So I was checking to see what the next was in the slide. What was the question?
In case of any issues running into integration, were there any tools for debugging?
Forums and...
I'm not aware of any particular specific toolkits. Maybe I can get back to you on that.
Have you faced something specific or more of a general, where do I go for help when something goes wrong?
Yeah, so I had the case in which I was trying to do the request and it was not getting. So I was not getting a response from either the client or the server, and it was very hard to know where things got lost. And since everything's done using the gRPC, I mean, on the LabVIEW side, I know how to do it. But on the gRPC, we're like, what do I do next? I stop at the DLL, the LabVIEW call.
No, that is indeed a black box, and we can't get much out of sniffing the TCP traffic either because it's all encrypted. That is, I think, an area for improvement. Hopefully, more infrastructure will be added to enable debugging. Yeah.
Was there a question over there? No? Okay.
All right. Thank you, everybody, for
There's
coming.
a few more. Yeah.
Yes. Last but not least, this was a joint effort between KLA and Soliton, and these are the few key team members. They were all not able to make it, and we are presenting here, but it's a bigger team effort than the two of us standing here. Thanks to NI and to anybody who contributed to the Git repos. 2 of them are right here. Dan and Casey, the big open source initiative from NI, we welcome that. We hope to contribute to that. In fact, we're wondering if we can work with our legal team to see if we can open source what we did.
That'd be cool.
Yes.
Thank you.
Thank you.